Welcome to Maths with EJD. Here we'll be talking about types of functions in set theory. And the first type of function we'll be looking at is what we know as one-to-one or injective function. One-to-one or injective functions. Okay? One-to-one or injective functions. Of course, as the name implies, right? It is one element mapped to another one. So let's go. We say that a function f, which maps set A to set B, is injective. It is injective. That means injective means one-to-one, right? It is injective, that is, it is one-to-one. If different elements in the domain, A map to different elements, they map to different elements in the codomain, B. So if you are talking about functions, right, and you have two sets, the first set is the domain, while the second set is the codomain. And you have a function to be one-to-one or injective if each element in A or different elements in A is mapped to a unique element in B. So no repetition of the codomain element, right? For instance, let's see. Okay, I think this is that point where I get to switch up markers. So let's go blue, and then let this be this multicolor stuff. Okay, so if A is equal to 1, 2, 3, and B is 4, 5, 6, for instance, and then we have this function, right? We have f is the function 1, 4, 2, 5, 3, 6. So you can see here that each this may be a bit not clear. Okay, so what, so you see 1, 4, 2, 5, 3, 6. So each one has its own element in the codomain. That is the idea of one-to-one. So so and f is this, right? F is all this. Then we can say that f is injective. F is injective because no two elements, in the domain A map to the same element, in B. So each person has its own, so it's a kind of monogamous marriage happening right here. That's the idea. So one man, one wife. That's the idea for those who believe in monogamy, right? Their function is injective or one-to-one. That's the thing. Okay. So we go for the next type of function. And that is onto. You know, we've talked about one-to-one. Now we want to talk about onto. So we have onto function. Onto or surjective. You know, one-to-one is injective, but onto is surjective. So we talk about onto or surjective functions. Onto or surjective functions. So here you say that a function f, which maps A to B, is surjective, or if you like, it is onto if every element in the codomain, B is the image, if every element in the codomain B is the image of at least of at least one element in the domain A, of at least one element in the domain A. So the whole idea is that if we assume that A is a list of men and B is a list of women, so the onto function is telling you that every woman, so if A contains men and B contains women, so it means that every woman in B finds a husband, right? That's the kind of idea. So of course, we don't care if there are other men that cannot find wives, but at least every woman in the B set has a husband. That's the idea of onto. So for one-to-one, it's like every man has his own wife, so to speak, and every wife has their husband. No duplications. But here it's like every woman at least find a husband, but we don't know about every husband finding a wife, That's the thing here. Onto. So we have that for surjective. So a function f which maps A to B is surjective or onto if every element in the codomain B is the image of at least one element in the domain A. So that's clear. So let's do this. We have for here, if A is 1, 2, 3, A is 1, 2, 3, and B is 4, 5, and B is 4, 5. Okay. And then we have a function, and we have a function f defined as 1, 4, 2, 4, 3, 5. So as you can see, right? Oh, okay. Well, maybe the idea. So here it's like if I use the idea of man and marriage, right? It looks like two women have one husband. Of course, in some places that happens, right? So at least every woman finds a husband, whether they don't have one or two husbands, we don't care. So that's the idea in this case. So and F is 1, 4, 2, 4, 3, 5. Then F is said to be surjective. So the main concern about surjective functions is that the two elements in the codomain are mapped to one element at least in the domain. That's the idea of surjective. So everything in the set B is used up. So then we say F is surjective because every element in B is mapped. Every element in B is mapped by at least one element in A. One element in A. So it could even be, we could have 1, 4, 3, only 1, 4, and 2, 5. So we don't care what happens to all the other elements. Okay. So we can have 1, 4, 1, 4, 2, 5, and so on. As far as every element in B is mapped to something in A, that is surjective. So let's talk about the last type of function here. The last type of function is bijective. Let's talk about bijective functions. So we have injective, 1-to-1, surjective, onto, and bijective. So bijective functions. Bijective functions. Okay. So we say that a function f which maps A to B is bijective if it is both injective, and surjective. It is both injective and surjective. So this means there is a one-to-one correspondence, one-to-one correspondence between elements of the domain which is A, of the domain A, and the codomain which is B. Okay, so let's see, for example, if, okay, I guess I just want to change it altogether. So if A is equal to 1, 2, and B is 3, 4, and then we have the function as 1, 3, and 2, 4. Okay, 1, 3, 2, 4. Then we say, then F is bijective. F is bijective because it is both, it is both injective, it is both injective, it is both injective, that is, it is, so that means no two elements, no two elements, no two elements in A map to the same element in B. That's 1 to 1. Map to the same elements in B. And also surjective. So it is injective and surjective. So it becomes bijective and surjective and surjective. Why? Because every element, because every element in B is mapped by exactly one element in A. So those are the three types of functions we talk about. We have one-to-one, which is injective. That is one-to-one. Onto is surjective. Everything in B is mapped to something in A. I mean, each thing in B is mapped to something in A. And then bijective, it is both injective and surjective. Then we say it is bijective. Okay, so let's talk about some applications. Applications of functions. These functions we've talked about. Now, what are the applications? Applications of functions in set theory, that is. So, number one, let's talk about injective functions. Injective functions are used. They are used in cryptography. Cryptography talks about security, things like passwording and all that. So injective functions are used in cryptography to ensure unique encryption. To ensure unique encryption. So that, if you're using a password, you don't want it to be the password another person is using for security reasons. So that's one-to-one. So each person, that's why fingerprints, right, and facial recognition and things like that are used for security stuff because they are unique to every individual. Okay. Then what do we use surjective functions for? Which are onto, that is, every element in the codomain is mapped to at least one element in the domain. So we see that surjective functions are important. They are important. Surjective functions are important. I feel like changing the marker. Can be that perfectionistic sometimes. Sorry. So unique encryption for injective, right? So next one, surjective functions. Surjective functions are important. They are important in solving equations. In solving equations. Where every possible output, where every possible output has an input. Every possible output has an input. So surjective functions are necessary in that situation. Every every possible output as an input. Okay. Lastly, we have the application of bijective functions. So bijective functions are used, they are used in algorithms. They are used in algorithms that need reversible. They are used in algorithms that need reversible mappings. Algorithms that need reversible mappings, such as inverting a function, And with this, we come to the end of types of functions in set theory. So you don't want to miss videos that are still coming your way. So because of that, you want to subscribe to this channel. You also want to hit the notification bell so you can get alerted each time a new video is released. Then, of course, feel free to comment. I mean, if you want me to teach something or you want me to clarify something or you have a particular problem to solve, feel free to tell me somewhere, maybe in the comment section, or if you have seen this on Facebook, you can also talk to me there. Then, of course, always like and share so that more people can get to enjoy the same benefits. Thank you for always stopping by. See you next time. Bye.